Hey guys, how are you doing? Are you feeling good? I hope so. We're gonna talk today about transformation geometry, specifically the reflection. Let's get started. For example, when I give you a shape like this one, this shape is called what? Do you know? Okay, just guess. Excellent, coronavirus. Okay, when I gave you this shape and I asked you to reflect it in y-axis, this line, the mirror. So we have here a mirror, like the coronavirus is standing in front of the mirror. So where's gonna be the image of it? Yes, great, somewhere here. How can we get it exactly? Just count how many units from the center to the mirror. For example, it's gonna be 1, 2, 3, and 4. So we're gonna count again from the mirror or behind the mirror 4 steps. 1, 2, 3, and 4. So the center is gonna be here of the image, and I'm gonna draw the same shape here exactly and try to keep the same size. Okay, and we're gonna draw these stuff. So we got the image now. Okay, so we have the same distance here and here exactly, and we have the same size. It's very important to consider the same size. And now let me give you another question. If I have here a triangle, this triangle like this one, and now you're gonna reflect it in the same mirror, which is y-axis. Where's gonna be the image? Great, it's gonna be here. How can you get it? So count the distance from the vertex to the mirror. It's gonna be 1 step, so 1 step here, and here 2 steps, so count 2 steps is gonna be here, 2 steps is gonna be here. Now join these vertices to get the image of the triangle, and you're gonna notice something here. Look at this. The original shape looks at the mirror, and the image looks at the mirror too. It's very important. So the shape is going to be flipped. Don't forget. It's a very important word, flipped. Okay? Let me give you another question. If I have a point on the mirror itself, where is going to be the image? Well done. It's going to be on the same point. So there's going to be the original and the image at the same time. Okay, that's it. Okay, we need to study the mirrors. For example, if I have here mirrors, a lot of mirrors, how can we define each mirror? Its equation. For example, I have here y-axis, this y-axis. Okay, y-axis here, and here this line is called what? Well, I'm gonna write x. If you said x equals something, why? Because this line intersects what? Intersects x-axis at a point. This point is what? 1. I'm going to write x equals 1. So if the straight line, horizontal or vertical, so you're going to write x or y according to that line passing through what? Through the x-axis or intersects x-axis or y-axis. If it intersects x-axis, you're going to say x equals. If it intersects y-axis, you're going to write y equals. So for example, the blue line here, so we're going to write what? X, and you said y equals. Why? Because this line intersects at 4 on y-axis. So we're going to write y equals 4. Another line, the green one, you're going to write here x equals, because the line intersects x-axis. Great. At what? Yeah, -4. Another one, the red one, what are you going to write? Great, you're going to write y equals. Why? Because the red line intersects y-axis. Equals what? Just look at this point. It's going to be -5. That's it. And we have special cases if I have the line inclined like this one. So what are you going to write? You're going to write y equals x. Why? Because the line here, you're going to find that, notice something. The line consists of what? The diagonals of these squares. Look, here we have these points, like opposite points of the squares on the grid. Exactly. If you have this case, I'm passing through the origin point, so you're going to write directly y equals x. So the opposite is going to be y equals negative x. Excellent, because it's declined. Here inclined and here declined. Okay, now we studied the mirrors because we're gonna solve according to the mirror, of course, any reflection according to the mirror. Here we have P and we have Q, and I ask you to describe fully the single transformation which maps shape P onto shape Q. So we have P, we're gonna move it or do something to P to put it over here. Look, the shape is flipped. P, we flipped it to be Q. So of course it's gonna be what? Great, it's gonna be reflection. So the first word I'm gonna write reflection. Okay, comma. Now, in which mirror? You have to mention the mirror. So when I ask you about the reflection, you're gonna mention the word, which is reflection, and which mirror. I'm gonna write here N. Where's the mirror? The mirror is gonna be the midpoint between the vertices, of course. So for example, this point is corresponding to this point. Look, we're not talking about this one now, so ignore this line. We're not talking about this line, by the way. So if I have this vertex and this vertex, so count the distance between them exactly. So 1, 2, 3, 4, 5, and 6. Okay? So the midpoint is going to be here exactly between them. Okay, another line. 1, 2, 3, 4, 5, 6. So it's going to be the same point. So when we're going to draw the line or the mirror is going to be standing. It's going to be vertical line between them exactly. Sorry, it has to be straight line. You have to use the ruler. Okay? So this is the mirror. Now you're going to tell me this mirror is called what? X equals or y equals? Great, you're going to write x equals because this line intersects what? X-axis. Look, this line intersects x-axis at 2. So you're going to write here x equals 2. What are you going to write here down? Reflection and x equals 2. Got it? Okay, let's solve another question. Yeah, we have the same question but different required. He's saying here, reflect the Q, the shape Q, and the line y equals x. So the drawn line here. So you're gonna reflect this Q. How can you reflect it? You're gonna count the distance from the vertices to the mirror, to reflect it behind the mirror. Look at this. You're gonna count from this to this. Look. Why you didn't move in this direction? Look. Why you didn't move in this direction? Why didn't say I'm gonna move in this direction? Because this is the shortest distance from the object to the mirror. So it's not allowed to use this line. You're gonna use this directly. Now we're gonna draw again. So here we have a diagonal. So we're gonna draw the same diagonal to put the point. For example, this A, I'm gonna write here A dash. And this point, I'm gonna move 1, 2.5. So I'm gonna move again 2.5. 1, sorry, half, 1, 2. So 2.5 here. 1, 2.5. So this is the second point, which is B, for example. So this is gonna be B dash. This is gonna be C, and this is gonna be D. So don't change the letters. Now we draw 2 lines, 2 points. Now we're gonna count from C. 1, 2, 3.5. So half, 1.5, 2.5, 3.5. So the point is going to be here, the C dash. And now count from D. 1, 2, 3. So count from the mirror or behind the mirror. 1, 2, 3. It's going to be here. Now write here D dash and join them. So join them according to the corresponding letters or respectively A dash, B dash, C dash, D dash, and close the shape. It's gonna be like this. Okay. What are you gonna write inside it? He said label the new shape R. So I'm going to write R inside it. Okay. Next one. On the grid above, reflect shape R in the line y equals negative x. So he didn't draw the line. So it's very important to remember that y equals negative x means the decline here. I'm going to draw here a line passing through all of these diagonals of these squares on the grid. So look at this. I'm going to draw here this line. You have to use the ruler. Okay, now we're gonna reflect this shape over here according to the mirror, of course. How can just count the distance, or count how many units to the mirror? We have two diagonals, so I'm gonna count two diagonals, 1, 2. I'm gonna put the first point. It's better to write here letters A dash, sorry, A. I'll not write A dash, of course. A, B, C, and D. I'm going to write here A dash because it's the image. Now we're going to count from B. 1, 2, 3 and a half, 3 and a half. So here 1 and a half, 1 and a half, 2 and a half, 3 and a half. So it's going to be here. I'm going to write B dash. Great. C, 1, 2, 3, 4 and a half. So I'm going to count half, 1 and a half, 2 and a half, 3 and a half, 4 and a half. So it's going to be here C dash, D dash, 1, 2, 3 and a half. So half, 1, 2, 3 and a half. It's going to be here. We have different ways to get the answer, but if you prefer this way, no problem. So join them respectively. Of course, you're going to use the ruler. Don't forget. Did he say label it? No. So I'm going to write the same letter, but I'm going to write what inside? R dash. So R dash. Let's solve another question. And the last one. He's saying here, describe fully the single transformation that maps shape P onto shape Q. P to Q. So it's going to be what? Translation? No. No. Why? Because the translation keeps the position. It's inclined in this direction, here inclined in this direction. So it's not allowed to say translation. Maybe rotation? No. No. Maybe we're going to say rotation. Do you know that? If I have the center somewhere here. But if you got an easy answer, no problem. You're going to say what? Reflection, because the shape here is flipped here. Is that right? So, but you have to search where's the mirror. Where's the mirror? Of course, it's going to be between them exactly. For example, if I have here 1, 2, 3, 4, it's going to be the half distance or the midpoint between them. Exactly. The mirror is going to be what? Straight line. And this line is going to be horizontal like this. So, can you define this equation? The equation of this line is going to be what? Excellent. It's going to be y equals 1. Do you know why y? Why we wrote here y? Because the line passing through y-axis. So y at which point? At 1. So I wrote y equals 1. Great. So I'm going to write, the answer is going to be what? How can I describe it? I'm going to say reflection or reflect P in line y equals 1. Thank you for listening.